In this question, we have been given the sample space which consists of outcomes E1 up to E10, and then we have been given two events, event A and event B. First, we need to find A intersection B, right? What is the intersection of A and B? If we can look at the graph here, A intersection B basically consists of elements which are a part of both A and B. So all the elements which are a part of event A and of event B. What do we have in A intersection B? So let's look at the common elements between A and B. So we can see that E3 is a part of both A and B. So that comes into A intersection B. Then E5 is a part of A, but it is not a part of B. So therefore, it does not come into A intersection B. Then we have E6. E6 is a part of both A and B. So therefore, it comes into A intersection B. E10 is only a part of A, but not a part of B. So doesn't come in A intersection B. Similarly, E4 is only a part of B, but not of A. So does not come into A intersection B. And E9 is a part of B, but not of A. So again, it will not come into A intersection B. The second part of the question asks us that what is the union of A and B? Now, what do we mean by union? If we can look at the graph here, A union B represents the area such that the outcomes are either a part of A or a part of B or a part of both A and B. So, any outcome which is either in the event A or in the event B or in both the events A and B will form a part of A union B. So let's see what are we going to have in A union B. So firstly, E3, yes, it's going to come because it's a part of A and B both. But whenever we are doing union, we have to keep in mind that the common elements have to be written only once. We don't need to write the common elements twice or thrice, how many ever times they are getting repeated, we only write them once. Then E4 will come because it is a part of B. E5 will come because it is a part of A. E6 will come because it is a part of both A and B, but it will come only once. E9 will come, and lastly, E10 will come, right? So this is how we get A union B. The outcomes in A union B are E3, E4, E5, E6, E9, and E10. The last part of the question asks us that is the union of A and B collectively exhaustive? What do we mean by collectively exhaustive? Collectively exhaustive means that whether the union of A and B consists of each and every outcome of the sample space S. If the union of A and B consists of all or each and every outcome of the sample space S, then we are going to call it collectively exhaustive. If not, then we will say that no union of A and B is not collectively exhaustive. So let's see here what we have. Our sample space is given here. The very first element E1 is actually not a part of A union B. So in the initial stage only we can say that it is not collectively exhaustive, right? Similarly, E2 is not a part of A union B. E3 is there, E4 is there, E5, E6 is there, E7 is not a part of A union B, E8 is not a part of A union B, E9 and E10 are a part of A union B. So we can say that since A union B does not consist of each and every outcome of the sample space S, therefore it is not collectively exhaustive, right? Therefore, it is not collectively exhaustive.